Okay, well now we're going to look at finding a missing side length of a right triangle using our trigonometric functions, or the values of our trigonometric functions. And we're going to do this over the next couple of examples, but first we start with some trigonometric values for special angles. And this is kind of a precursor, preliminary, if you will, a little bit of an introduction to what we're going to eventually come to know as the unit circle. But on page 791, you'll see this chart right here. And this is giving us values of the sine, cosine, and tangent of 30 degree, 60 degree, and 45 degree angles. And we can see here that the sine of 30 degrees is 1/2. The cosine of 30 degrees is the square root of 3 over 2. And the tangent of 30 degrees is the square root of 3 over 3. The sine of 60 degrees is the square root of 3 over 2. The cosine of 60 degrees is 1/2. And the tangent of 60 degrees is just simply the square root of 3. And then on our 45 degree angles, the sine of 45 degrees is square root of 2 over 2. And the cosine is also square root of 2 over 2. And then that's going to mean that the tangent of 45 degrees is equal to 1. And it's a good idea to begin to start working on memorizing these trigonometric values for 30, 60, and 45 degree angles, because they come up so much in our study here of trigonometry. And in this set of examples, example 3, which is over on page 792 of our textbook, we're going to use these special values to find the length of a missing side. But then in the next example, in example 4, which we'll take up momentarily, we're going to use our calculators for any type of acute angle, not just these special angles. So let's start right here. We have an example here. We have a right triangle here, 3A, and we're told that we've got 60 degrees. So we got a 60 degree angle, and we are given the x is the adjacent side, and 14 is the hypotenuse because it's opposite the right angle. And so let's see, so we've got adjacent and hypotenuse 60 degrees, so we want to use the cosine of 60 degrees. And the cosine of 60 degrees is 1/2. Now, if we know the cosine of 60 degrees, we can solve for x. And let's set it up like this. Because what we're trying to find is x, which is the adjacent side. So if the cosine is 1/2, so that's going to be that 1/2 is now equal to, and remember, if we're using SOHCAHTOA, well, the cosine is, that's A, adjacent over the hypotenuse, then we can set this up as x, 1/2 equals x over 14. And if we're going to solve for x, well, we're dividing by 14 right here, so we want to then multiply by 14. I'm going to take this up right here, so then I'm going to have 14 times 1/2 equals x, and that's going to give me 14 over 2 equals x, and so x is going to equal 7. So this missing side length right here is in fact 7 for a 60 degree angle, and we worked that off the cosine because we were asked to find the adjacent side and we were given a hypotenuse. All right, we're going to take a look at one more here in this set of exercises. Okay, so I've left this little chart here of these special angles, and again, you want to try to begin to start committing those to memory. But I'm asked to find the missing side, and I have a triangle here, And let's see, it's a 45-degree triangle, so I'm going to be looking at one of these three special angles, and I'm given that this side is equal to 10. Well, that's opposite the 45-degree angle measurement, and I'm going to go ahead and write SOHCAHTOA up here so I know which way I want to go. And I'm asked to find x, and so this angle for x is opposite the right triangle. So, and that's the hypotenuse. So this is the hype, this is the opposite. So it looks like I want to use the sine of 45 degrees to solve for x. And here I'm told that the sine of 45 degrees is the square root of 2 over 2. So I can set this up as the square root of 2 over 2 is now going to equal 10 times, 10 over x. So I'm trying to find the hypotenuse. All right, so algebraically, if I'm dividing by x here, then I can multiply, and then I can say that x times the square root of 2 over 2 is equal to 10. And then if I'm going to isolate the x, I can turn around here and divide 10 by the square root of 2 over 2. So I can then say that x is equal to 10. Well, if I'm going to divide by the square root of 2 over 2, that's the same as multiplying by the reciprocal, which is going to be 2 over the square root of 2. And so then x is going to equal 20 over the square root of 2. And I could rationalize the denominator. If I did that, I'd have 20 times the square root of 2 over 2, or 10 times the square root of 2 over 2. Or I think it's asking me, it's asking me to find the value and round to the nearest tenth. So I'm going to save myself all of that. And I'm just going to go into my calculator, and I'm going to take 20 and divide it by the square root of 2. And when I do, and I'm going to round this to the nearest tenth, I'm going to say that this hypotenuse, or this missing side, is equal to 14.1. 20 divided by the square root of 2. So we're using SOHCAHTOA, special angle relationship, SOHCAHTOA, to solve for the missing side. In this case, it was the hypotenuse. And again, as I said, in the next set of examples, we're going to take angle measures, acute angle measures that are not 30, 60, or 45, and we're going to use our calculator to solve for those. And we'll demonstrate that in just not too long.